Okay, so yesterday, I'm gonna open up the link. Yesterday, well, they might have said it differently yesterday, the notation, but let me write two things up here. So we can write it like that, or some of you started to notice like they do use capital F and lowercase f differently, and they do mean different things. So it's almost like they're two separate letters, two separate variables. So these are the same thing. I'm writing the same thing up here, just two different ways. And they'll present this to you a lot, and then ask you questions about g of x. So they're telling you that g is the integral of f, or in this case, they're telling you capital F is the integral of lowercase f, which is annoying and confusing, but you get used to it. The capital F represents the integral of little f. But we can, like, I don't think most people think about it this way. I think most people would think about it in the way that, okay, let's take the derivative of both sides and see what we get. So what's the derivative of g of x? Would be g prime of x. And then this is what we did yesterday. So I plug in the top, and then I multiplied by the derivative of the top. So I multiply by what? By 1. Minus, I plug in the bottom, but I'm not even going to write it because I'm going to multiply by the derivative of the bottom, which is 0. So this becomes true. So you can phrase it either way, that g is the integral of f, or f is the derivative of g. But what I think of is like in order from top to bottom. So g of x is up here. The derivative of that is g prime of x, which I could also call f of x. G double prime of x would be f prime of x. And we're just trying to relate that back and forth to each other. Back and forth to each other. This is the same thing. I'm going to do it again, but just to kind of practice the capital letter thing. So if I take the derivative of both sides, the derivative of capital F of x is capital F prime of x. I take the derivative of this side, you'll get little f of x. So again, you can phrase it either way. Capital F is the integral of little f, or little f is the derivative of capital F. And then I just think about it like tiers. Like that's the big guy, that's the original one. And then since it's the integral of little f, then little f must be the next one down. Well, that's the same as f capital F prime. This might make more sense when we like do a graph or a problem with it, but does that make sense that they go back and forth at least? Questions on what I'm doing up here, or is this just like rambling nonsense at this point? Yes to rambling nonsense.
No, this helps from yesterday's seeing it for the first time and seeing
Okay.
this explanation helps.
Okay. That's cool. So let's look at how you'll be asked to use it. So this up here is what I was talking about. So they give you this, and then if you take the derivative of both sides, you get that. And what that means, to me, the easiest way to do it is say, okay, the original function was f of x. Because if I integrate f of t, I get f of x. So that's like going up a level. I always think about like integrals go up and derivatives go down. So like positions up here, velocities here, accelerations down here. So if you take the derivative, I go down that list. If I take the integral, I go up that list. So f of x is on top, like it's the topmost of that list. The derivative of capital F is lowercase f. Then I see concavity down here, so I might have some second derivative stuff to worry about too. So I'll just keep going. So the second derivative of capital F is the first derivative of f. So they're asking us to fill out this chart two ways, which makes sense because there's kind of two ways to think about it. I want to know when the capital F of x is increasing. So if I want to know when capital F of x is increasing, what level of capital F of x do I want to look at? Increasing comes from slope, doesn't it? f of x, and I'm like, tell me when that function is increasing. What kind of graph? Well, I think I'm just gonna say the answer instead of trying to get you guys to say. F of x, capital F of x would be increasing when the derivative of capital X is greater than 0. You guys know that. We did this, I don't know if you remember it, but we did this in unit 5. This is just saying if I have a derivative graph that's above the axis, if I have a derivative above the axis, what's the original doing? It's increasing. Is that familiar? Um, and what this new lesson is saying is, well, now we know that those two things are the same. So we could also look and say, well, when is f of x greater than 0? Little f of x greater than 0. So that's like the point of what's going on here, is to realize that we can look at it either way. Yeah,
Is capital F like the original?
I would call it the original. So when I see this, and if I integrate it, that means I go up. Like to me, that means I go up to get to capital. So capital is at the top, and so it's the original. And then once I know that, you know, what if I use so if I integrate f of t, I get f of x. So doesn't it make sense that we're like this is on top, this would be the derivative? Does that make sense? Maybe, sort of. Let's keep going. I think you'll start to see it a little more as we go. And let's actually just go back to that chart. This graph. Welcome back to the chart, but that's kind of designed to be a review. I'm not sure we have the new concept down yet, so we probably shouldn't be. We'll see how it goes. Okay. So what I've got here, they're telling me G is the, so maybe this will be better because it's not the capital letters too. G is the integral of f. Okay. So if I were to put those in order, G is one level above x. Because if I integrate f, I get to G. Does that make sense? So when I integrate f, I get to G. That's like saying when I integrate velocity, I get position. So if I integrate velocity, I get position. So we're going up a level. Okay. Well, if this is a level below G, what else could I call this besides f? I could call it G prime. Exactly. So this is the point they're trying to get you to realize. And they give you this graph of f, and they ask you about G. But what you've got to realize is this is really also the graph of G prime. This is the key. Because now we realize, or hopefully we realize, that we're looking at a graph of the derivative. We have a graph of the derivative. That's like the whole point that I'm trying to make here. Should I like do that again? Talk through it again? Okay, yeah. So, first of all, let me just clarify what I mean by like up and down. So remember, if I take the derivative position, what do I get? Velocity. So to me, that's going like down the chain. If I take the derivative velocity, what do I get? Acceleration. Or just in general, like if position is centimeters and I take the derivative, what do I get? Centimeters per whatever it is. Centimeters per second squared if I go down another level. So when I talk about going up a level, I mean going backwards, like from second derivative to first derivative is up a level. From first derivative to original is up a level. So what I'm saying here is if I integrate f, so the integral of f has to go up there, right? I got to go up a level. Well, what is the integral of f? It's G. Fair enough? Now look at it like again, but forget this exists. If I go down a level from G, where am I at? Forget the f even exists. If I go down a level from G, where am I at? G prime. So what that tells me is these be true that f is the derivative of g. They're opposites. They go back and forth. So since g is the integral of f is the derivative of g. So I wrote it up over here like two ways. There's lowercase g and there's capital F. These are saying the same thing, just like with two different letters. So the main idea here is you have to understand that we are looking at f. They don't ask us anything about f. It's all g. So we have to know that f is really g prime. What is that? Okay. And that we are looking at a graph of the derivative. Are we okay-ish there? Okay. I think some of you are like, stop explaining. Some of you are like, I don't get it. So I'm just going to keep going. So relative min of g. So first of all, let's just like review what a derivative graph does. So when the derivative is above the axis, what does that mean the original function is doing? Positive derivative means positive slope means increasing. So the original function is increasing here, decreasing here because the derivative is below the axis, and increasing here because the derivative is above the axis. So when I ask for a relative minimum we want to go from like down to up, right? Decreasing to increasing. So that is going to be at 5.3. I don't know. What did he put in the notes? 5 point what? 5.4.
I said 5.2. I don't really.
Instead of worrying about the number, do we understand like what I'm doing there? Derivative above the axis means increasing. Derivative below means decreasing. So here, the original function went from going up to going down, which is actually a relative max. And here, the original went from going down to going up, which is where we get the relative. Questions there? Okay. Now, it asks about concavity. It's asking about the concavity of G. So, concavity comes from which level? Second derivative. So I want the second derivative of G, right? So I'm looking at the concavity of G. Yeah. Yes. So the second derivative, if I just take the derivative of this step, what's the derivative of G prime of x? G double prime of x, which is where we'll find out about the concavity of G, right? Well, if I take the derivative of this side, it's f prime of x. I don't have a graph of G, I only have a graph of f, so like this doesn't really help me. I can't use G double prime because I don't know anything about G. What I can use is f prime. So this is f. F prime, how do I take the derivative of a graph? I look at the slope, right? So like what is what is f prime here? 0, which means what's G double prime? 0. Are we concave up or concave down there? Neither, because it's 0. What are you chuckling at?
I forgot that they were both 0.
Okay. Here, what is true about f prime? Not f, f prime. Negative, because it's going down, right? So if f prime is negative, isn't G double prime also negative because they're the same? So then we are concave down from 2 to 4. So that's this one. I know I skipped it. But... And then, again, I want to know concavity of G. So I need to look at G double prime, but I can't see G double prime. So I'm going to instead look at f prime. And I want f prime for concavity. I want this positive, which means I want this positive, which means I want the slope positive. So that's from like 4 to 6. How's that? All right. Point of inflection. Well, I want the concavity to switch from up to down or from down to up. So here we were, f prime was here we are concave up, so that's a point of inflection. If you remember, points of inflection on the derivative graph comes from peaks and valleys. Is that one okay? Some people like love this stuff and it clicks right away and they think it's easy, and others have a lot of trouble with it. So please ask if I can go over it again. If G1 equals 5, what's the maximum value on the interval 1 to 5? So G of 1 equals 5. Remember, integrals are like accumulation functions. So right here, what they're saying is I've already accumulated 5 units. I don't care what G looks like, I just know that, because remember G is the level above them, so I can't see it. I know that when I start off, I have 5 units of whatever. Well, I'm going to keep accumulating. I'm going to look at 1 to 5. Well, where's the maximum value happen? Well, right here, I've added 2, right? Like if I'm at 5, by the time I get to here, aren't I at 7? Yeah.
How can you add if the slope is 0?
So now I'm integrating. How do you integrate a graph? Well, you find the area, right? Because they're not asking me, they're asking me about G. So basically it's going to be like this. So G of X is from A to X of that graph. Well, if I put, telling me this is 1. If I put a 1 there, let's just go through like piece by piece. What is the integral of any graph from 1 to 1? Like what's the area between 1 and 1? Is 0. So G of 1 is going to be 5, because that's what I start with, plus 0. Because I didn't accumulate any area going from 1 to 1. But G of 2, now I got to plug in a 2 here. Should be a dt. So what's the area from 1 to 2? Is 2, but I started at 5. So now I'm at 7. Because as I go to the right, I just pick up that area. Like I had $5 in my pocket. When I went through there, now I find 2 more. When I go to 3, I'm going to find 1 more. Because that's like 1 square, really, right? Let's just split it into 2 parts, kind of. So G of 3 would be from 1 to 3. And that'll be 5 plus 2 plus 1. So it's 8. Well, now, when I go to 4, am I going to be adding or subtracting to 8? I'm going to be subtracting. So the question you have to look at is, did I subtract more than I, like, well, no, I don't have to look at anything. Never mind. If I'm going to be subtracting, where did the maximum value happen? If I'm going to start subtracting from now on, so if I do G of 4, it's going to be 5 to start with, plus 2, plus 1, minus 1. So now it's 7. And when I go to a 5, I'm going to accumulate more negative area, which will subtract more from the area. So what was the maximum area? 8. And where did that happen? Is that x equals 3. Let's look at let's just talk through a couple other versions of that. That'll just make up. But before I erase that, I think I can clarify what is written on the board. Alright, let's say if G of 0 equals 2, just change this to G of 0 equals 2 and change this to 0 to 3. So see if you can find the maximum value and where it occurs. 0 to 0, that's going to be no area, right? If I go from 0 to 1, what's my area going to be? Those two boxes. If I go from 0 to 2, what's my area going to be? 1, 2, 3, 4. If I go from 0 to 3, what's my area going to be? It's going to be 5. Do people understand this besides Noah? Okay. Okay. So the biggest thing I could get would be to put a 3 there. And the maximum value at that spot would be my initial value of 2 plus those 5 that I added, which would give me 7. Give me like thumbs up, down, middle. Yeah, you can do like tilted. Just don't flip me out. Okay. Wait, who's the?
Please shut up.
This is in the notes, right?
Oh my god. This is my mind.
Okay. Well, that makes no sense.
Comparing it to a couch.
Oh.
No, it doesn't make sense.
Yeah, no, that's fair. Okay. Let's, I want to go back and fill out that table. So remember that f prime, capital F prime equals lower f prime. So increasing when capital F prime equals lower f. So both of these are the derivative of capital F. They're just written different ways. So either one of these could be true. Decreasing then would be if f prime of x is less than 0, or lowercase f is less than 0. These are capital, these are supposed to be lowercase, yeah. Relative max. What are we looking for on a derivative graph? Above to below the axis, right? So f prime, capital F prime of x goes from positive to negative, or lowercase f of x goes from positive to negative. So that relative min is the opposite, right? So capital F prime goes from negative to positive, or lowercase f goes from negative to positive. Alright, concave up happens when the second derivative is greater than 0. What we're trying to get across is if it's the second derivative of capital F, what is it for lowercase f? The first derivative. So at lowercase f prime of x has to be greater than 0. Concave down is the opposite. And then a point of inflection would be f prime of x, or f double, capital F double prime of x, switches signs. And like for relative max and min, it matters which way you switch, to positive to negative or negative to positive, but for concavity it does not. So the same version over here is little f prime switches signs. Questions there? Alright, I think do number 1 and 2, or try number 1 and 2. doesn't actually understand it, or do you want to rush and have a quiz on Thursday? You know,
I bet they're the most confused I've ever been in my entire life. They're about this 10 minutes. Now I'm in the middle.
here.
Yeah.
You're
I was
getting,
at a fat thumbs down, but now I'm in the middle.
okay. So today I just want you to do 1 and 2. Let's make sure we're solid there, and then we'll worry about the rest. Do you want me to go through that one with you or show you? There's one little thing that, yeah. There's just one little thing that I think will help you. So I think you probably got.
I is the worst.
Yeah, if you're looking at if you're concerned about I already, pay attention. If you didn't get to I yet, worry about the other stuff first. The part I on both is pretty tough. So I'm going to take the derivative of it because if I want to know where h has a relative minimum, that information comes from the derivative, right? All right. So h prime of x is plug in the top, so it'll be f of 2x minus 7 times the derivative of what you plugged in minus, but can I just skip the minus part? Okay. And if it's a relative minimum, I want that derivative to equal 0. Well, that happens twice, but only one of those is a minimum. One's a maximum. So is the minimum the 2 or the 6 point? Who knows? It's the 2 because we're going from decreasing to increasing. So I can multiply both sides of this equation by a half and just get this. Like that times 2 isn't really accomplishing anything, you know? So then here's the part that I think is like harder for people. So it is true that I need this to happen, right? It is also true that f of 2 equals 0 from this graph. That is a lowercase f. Do you agree with me there? All parties to be convinced.
Yes. Yes.
Okay.
Yes.
Well, if this and this both equal to 0, then don't they equal each other? So that's the stuff that, like, I watched his video for this, and I don't think he explained that stuff very well. But now I can set them equal, and then I can solve it. So I think this piece is the part that was helpful. Yeah. Yes.
Or like
Do you want me to do I for 2 or do that one?
I just got to I.
Okay. So I want to know where h has a relative maximum. Relative maximum information comes from the derivative level. So I want to take the derivative of h. Well, that's what we learned how to do yesterday. So this is an integral. We're going to take the derivative of it. So we're going to plug in the top and then multiply by the derivative of the top. So times 2 minus, I'll plug in the bottom and then multiply by the derivative of the bottom. But that just makes all that go away, you know? And then if it's a relative minimum, I want my derivative to equal 0 because that's like the turnaround spots. So I'm just going to start solving this equation. All I mean by that is I'm going to multiply both sides by a half. I'm just pointing out that 2 is basically irrelevant because a half is 0 is 0, so it's like the same. Well, now I'm going to go look at my graph, and I'm looking for a relative minimum. So where on this graph does this is the derivative from there. Where does a minimum occur? Yes. So now I also know that f of 2 equals 0. And 2 matters because it's the minimum. And it's also true that at that spot, the derivative is 0. So just read the graph. Well, if this equals 0 and this equals 0, then I can set them equal to each other. Yeah.
I get how to do H for number 1. For number 2, I don't understand where DT gets with the graph. Or like why in the first problem in H they left out the DT, but in the second one they kept it.
This?
Yeah.
What is the maximum value from 2 to 9? So it's going to be 1 plus, so the max happens there,
Yeah.
right?
Yeah.
taking my initial value and then I'm gonna add up this area from 2 to that maximum value
Yeah.
and see what I get. So 1, 2, 3, 4, 5, 6, 7.5, I think that is.
Yeah.
So 1 plus 7.5. So 8.5. I know you're asking about like DT though. Like they might have written a fancy notation for it, but that's all you're doing. It's just like adding it up.
I think I just did the math wrong. Cool. Okay, I actually get it. That's really stupid. Anyways.
You're good?
Yeah.
Okay.
Can you jump to 3 for a second?
For a hot second. Only for a hot second. No longer.
Oh, I see what you're saying.
Okay,
Try to teach me.
Yeah, because like the first one they left it out. And the second one.
Like just go through it.
well, no, just, it's a lowercase f. Why, how does that, is it because there's not a function in why? How can it be a
You can
lowercase?
call it whatever you want.
But if you,
So what this tells me is, I understand it's annoying, but I'm also saying it doesn't really matter. If I integrate, I go up a level, so f of x is up here, which makes this the derivative.
Okay, that's all I wanted to know.
And then you put in your
So you
calculator.
can call sine of 1t a of x. It doesn't matter.
You call it Bowman of x if
Yeah,
you want to.
okay.
And then you put Davis here, and Davis is the integral of Bowman or something. It doesn't really matter.
No, that-
Which, since it doesn't really matter, it even annoys
Why?
me more than
Yeah,
when you use the same. Yeah.
Right, okay.
But I don't get to make the rules.
So
Yeah.
I think instead of having that, we just should set it to Bowman.
What?
We should just have Bowman instead of
So I would like try the second part beyond 1 and 2. See where you get stuck. I'll take questions on them. I'll give you more time to do that tomorrow. I'll also give you the review tomorrow. So we'll finish up this lesson tomorrow, and I'll give you the review. Thursday we'll have time to answer questions, work on the review, whatever, and then Friday will be your quiz. Sorry, man.
No, it sounds out of
Maybe well.
Just go home and cry.
I think everyone's doing that this morning. No. Okay. I don't know. I did the rest of it. The test prep is actually pretty good. But like, I don't know how to do the calculation.
You just gotta graph the
Maximum value is gonna be right.
Yeah, I didn't.
So you
Did I
take
what? March 8th. It's like, well, okay, why would we do that? No, you haven't, but I will. I can't, I think the first one is all written down.
Bowman of x is sine of 1 over x.
I'm very excited. I'm very excited. I'm super excited. Because I know everybody was like this.
plus like
Matthew, does number 3 just like you put in the calculator and you see where it crosses?